Hi students, in this section we are going to learn nomenclatures of the coordination compound, which is called Iupac, that is International Union of Pure and Applied Chemistry, that we were usually in organic chemistry. In inorganic chemistry also available, that is Iupac naming rule. See, the complexes, the cationic complexes are possible, anionic complexes are possible, then non-ionic complexes are available. First, the general rules are here. The ligands are, the first rule is, ligands are named first, followed by metal, followed by the oxidation state of the metal atom. This is the way you have to name. First ligand, then metal, followed by metal, then followed by the oxidation state of the metal. Then second is the oxidation state of the metal ion is indicated by the Roman numerals only. You have to write the Roman numeral number. Then the third rule is no space should be left between the ligand name and the metal name. Similarly, no space should be left between the metal name and the parenthesis is considered as a single entity. Then, more than one simple ligands are present the same kind of the compound, you have to write di, tri, tetra like this. It's used to depending on their numbers, like di for 2, tri for 3, like this. You can write like this. Then more than one complex ligands are named with bis, that is for 2, bis for 2, tris for 3, tetrach is for 4, pentach is for 5. Okay. And usually that more than one ligands, their names are written in the alphabetical order. Okay. Now we will see the example. See, now we will name the cationic complexes first, then followed by anionic complex we will see, then followed by the non-ionic complexes. First, how to identify the compound, the complex is cationic, whether the compound is anionic or neutral. Simple one. Take this compound, the complex, look at the counter ion. The counter ion present in the right hand side. Simply present in the right hand side means they are generally cationic complexes are possible as cationic complexes. Or sometimes positive charges are given like this. You can easily find this is a cationic complex. Sometimes negative charges will be given means that is easily find that is an anionic complex. Here the suppose without giving this like this means how to identify. Look, this is SO4, this sulfate ion. The sulfate is what? The charge is what here? -2. So the charge is -2 means just opposite charge of this complex. So that this will be +2. So this is a -2 means this will be +2. Already I said the complex charge should be equal to the metal atom. That means equal to this complex ions. Here the NH3 is a neutral ligand. So that 0. Then here +2 is in the complex charge, so that the it should be balanced, it should be satisfied with the charge, so that it will become copper also become +2. So here the metal is oxidation status +2. So first you have to find the metal oxidation state. Here the copper having +2 oxidation state. Now I am going to apply the rule. First the rule is what? Ligand is named first. Here in the complex you have to look only the complex first. So in this complex ligand, only one kind of ligand is present. So this amine. So amine is a ligand. So ligand is named first means how many ligands are present? 4. So that you have to use tetraamine. So you can cut 1A, that is tetraamine. Then here, what is given here? Copper. Simply write copper, that is ligand is named first, followed by metal. So that copper followed by metal, then followed by oxidation state of the metal. So here +2. So +2 means you have to write the Roman numeral. So tetraamine, copper, simply end with sulfate. So in complex ion, there is no space left between the metal and the ligand. It's considered as a single parenthesis or single entity. Okay, the name of the complex is tetraamine copper to sulfate. Okay, then look at this complex. This complex is FeH2O 6 times Cl3. Here the similar way you have to follow. First find the oxidation state. So Cl, what is the charge of chloride ion? -1. -1 into 3, -3. It will become -3, and the complex of the charge should be +3. Okay. Now here aqua, the water, the aqua is neutral ligand. So the neutral ligand having 0, charge is 0. Then this Fe, ion should be what? Definitely it will become +3 because of the whole charge of the complex and the complex charge. This should be equal. See here, this is +3 and the complex also having +3 charge. Now satisfied. Now naming it. Here aqua, this is aqua, so you have to use hexa aqua because of 6. Ligand is named first. Here ligand is aqua, so that hexa aqua, then ion. What is the oxidation state? +3. So that ion 3, simply write chloride. You do not write trichloride because the oxidation state automatically indicates it is a trichloride. Okay. Then look at this complex CONH3 6 times Cl3. Look at this. Ligand is named first, and this. Before that, you have to find again oxidation number of the metal atom, central metal atom. This is also -1 into 3. It will become -3. Then the charge of the complex should be +3. Then NH3 is also neutral, so 0. Then it should be CO, cobalt ion, as +3. Then name it hexa. 6 times are amines present, so that hexamine, hexamine. Then cobalt. What is the oxidation state of the metal? 3. So that write 3. Then chloride. Then look at this complex. Here already positive charges are given, so you have to find the oxidation number of the metal atom. Here the plus indicates it is a +1 charge. Ethylene diamine, the En symbol is ethylene diamine or ethane 1,2 diamine. We should say ethane 1,2 diamine. Why? Because mean Iupac name. Ethylene diamine is a common name. So that here ethane 1,2 diamine is 0 oxidation state because it is a neutral ligand. Then chlorine having -1. How many chlorine atoms are there? 2 chlorine atoms. So that -1 into 2, -2. So here +1, here -2. The complex charge and this charge should be satisfied. So that I am putting +3 of this complex mean, that metal ion mean, plus 3 minus 2, it will become plus 1. So, the charge of the complex also plus 1. Now, it is satisfied. Look at, this is ethane diamine, ethane 1,2 diamine, already di, so that it is a complex ligand. So, complex, more than one kind of complex ligands are present, mean you have to follow bis for 2, tris for 3, tetrakis for 4, like this. Now, we can write it here, this is chlorine is present, this is tetramine, sorry, ethane 1,2 diamine. So, in alphabetical order, you have to write first chloride, then that is C is first, then followed by E. So, write how many chlorine atoms are there? 2. So, that dichloro, that's my dichlorido. In 2004, before we can use it, we were using chloro. Nowadays, we are using chlorido. So, dichlorido, bis, because of complex ligand, bis, ethane 1,2 diamine, 1,2 diamine, cobalt 3. So, here charge is given, so that you have to end with ion. Okay. Here charges does not given, so simply you can finish it. Suppose charge is whatever the charge, plus or minus, whatever the charge, end with ion. So, dichlorido, bis, ethane 1,2 diamine, cobalt 3 ion. Then, look at this compound. Here also 3 different ligands are present. In this complex, 2 different ligands. In this complex, 3 different types of ligands are present. So, here what is the charge of the compound? First, you have to find the NO2 is -1 and Cl having -1, NH3 is 0. This -1 and -1 means this -2, so it could be +2. The platinum having +2 oxidation state, because there is no charge or there is no counter ion. So, this complex charge should be 0. That is why this will become +2. Now, name it here. This is amine, chlorine, nitro compound. So, 3 compounds are present. Here, first write ligand is named first. Here, which is the alphabetical order means amine. So, that how many amines are present? 2. Ammonia is 2. So, that diamine, chlorido, then nitrito, N, platinum, 2. Why I am using N means this is the nitrogen coordinate. There are 2 possibilities, that NO2 and ONO. They are simply called ambidentate ligand. This metal approaches, see, this approaches to the nitrogen coordination. Here, the metal approaches to the oxygen coordination. So, you have to find whether the compound is NO2 given like this or like this. Suppose NO2 given like this means you have to use O. NO2 given like this means you have to use N. So, diamine, chlorido, nitrito N, platinum 2. Now, we will see the anionic complexes. How to name the anionic complex. See, here also the ligand is named first, followed by metal atom like this. but before that, counter ions are present. So that first counter ions are named first, followed by ligand, followed by metal atom, followed by the oxidation state of the metal atom. Then simple changes, the metal atom ends with ate, that is ATE. The letter should be end with ATE, that is ate. Then the name of the metal is derived from the original word from which the symbol is derived. For example, sodium, natrium, the original name is natrium. Gold, that is the original name is aurum. So like this. So they are end with ate. Silver, argentinum. So end with ate means this will be Ag, silver is argentate. Copper is cuprate, that is for cuprum. Au, aurate. Fe, simply we can tell iron, but the original name is ferrous. So ferrum. So end with ate means ferrate. Cobalt, cobaltate. End with cobaltate. So now we will see some more example how to name the anionic complexes. Now we will see the example. See here the anionic complex. In cationic complex we have seen the counter ions are present in the right hand side. Here the anionic complex simply the metal ions present in the left hand side, that is the square bracket left hand side. Now you have to find the oxidation number of the central metal atom. This is only the central metal atom, okay. This is not a central atom, this is a counter ion, okay. Now the first example is K4 FeCN 6 times. So what is the charge of potassium here means usually the alkali metals having +1 oxidation state. So that here +1. So potassium having +1 into 4 it will become +4. This counter ion is +4 means the opposite charge is what? -4. Okay. Now you have to satisfy with the charge in the inside the complex. Now cyanide having -1, -1 into 6 it will become -6. Now here -6, this is a -4. Suppose if I put +2 means the charge should be satisfied. So here the oxidation state of the Fe ion is +2. Now we can name it. First the potassium you have to write the counter ion is named first. So potassium. Then again you have to follow the same method. Ligand is named first, leaves one space because the complex ion and the counter ion. So you have to separate the counter ion and the complex ion. Complex ion is considered as a single word, that is a single entity. So here cyanide, hexacyanido, ion, that is here original name you have to use. The original word is what? Ferrate. And the oxidation status 2. Okay. Potassium hexacyanido ferrate 2. Then look at this compound, this complex. Here also potassium is present. So that +1 into 2 it will become +2 and the complex charge should be -2. Then this is hydroxy. So hydroxido. Hydroxy having -1 charge. -1 into 4 -4. So here is charge is -2. So here is -4. If I put +2 in zinc, what happens? It will become -2 of this complex and the charge of the complex also -2. So it is satisfied. Now we can write it name the potassium first because the counter ion potassium. Then tetrahydroxido. You have to write tetrahydroxido. Then zincate. zincate, the charge of the metal is 2. So, this is the name, potassium tetrahydroxido zincate 2. Then, look at this compound. Here, the mercury, then charge is 1. Here, this will become minus 1, and thiazino is minus 1 into 4, minus 4. So, if I put plus 3 is here means the charge of the complex and the complex charge should be equal, that is satisfied. Plus 3 minus 4, the whole term is minus 1 and the charge of the complex is minus 1. Now, satisfied. This is plus 1. Okay. Now, write name as mercury. Mercury. Then write thiocyanato. So, how many? 4. So, tetrathiocyanato. Tetrathiocyanato cobaltate. The oxidation number is 3. So, mercury tetrathiocyanato cobaltate 3. Then, look at this complex. This plus 1 into 3 plus 3. So, the charge of the complex would be minus 3. This is oxalato. The oxalato having minus 2 charge. Minus 2 into 3 is 6. Minus 6. Then, the aluminum should have only one oxidation state, so that it will become plus 3. So, plus 3 minus 6, it will become minus 3. So, charge is satisfied. Now, name it the compound potassium. Then, this is trioxalato 3 times, so that trioxalato. Then, aluminate. Oxidation status 3. Okay, potassium trioxalato aluminate 3. So, this is the naming method for anionic complexes. Next, we will see the non-ionic or the neutral complexes. See, this is non-ionic complex. The non-ionic complex or the molecules are given in a one-word name. Here, there is no charge. In cationic complex, some charges here, anionic complex are charges here, but in non-ionic, that is neutral complex, there is no charge. So, this is a 0, means, see the carbonyl having the oxidation number is 0 because of neutral ligand. So, this is 0 means the whole term is 0. So, here the nickel don't have oxidation state. That's mean nickel having 0 oxidation state. Suppose 0 means you have simply write 0. That's for example, this is 4 carbonyl. So, that tetracarbonyl nickel. Here you should not write nickelate or whatever it is, just simply end with nickel. The oxidation state is 0. So, mention here 0. Tetracarbonyl nickel 0. Then here this is also same way 0 and carbonyl is 0 and iron also 0. Here write the ligand is named first. So, pentacarbonyl, then iron 0. Okay. Then the last one, look at this. Here the compound is carbonyl is 0 and here amine also 0 and this charge also 0. So, iron also here 0 charge. Okay. So, the compound will be the name carbonyl amine. So, which is first comes alphabetical order, you have to use amine. So, triamine. Triamine, then tricarbonyl, then ion 0. Okay, this is the rules of naming non-ionic complexes. Already we seen cationic complex, then anionic complex, then this is the non-ionic complex.